So what is the material that's actually being deposited?
Well, that depends on what you've built your reactor out of. At the very beginning of the nuclear age, we used something called Admiralty brass, I believe, a type of copper-brass alloy, and that obviously would have deposited copper oxide and all sorts of things like that. In more recent years, we've moved from using that into using stainless steel, which has been an excellent material all round and is still used in many plants and is still used in conventional plants as well. But in more recent years, the most commonly used materials have been nickel-based alloys, which are extremely good. They're very good at corrosion resistance. They have lifetimes well in excess of many of the other materials we've used for the past 40, 50 years. And they are being increasingly found to be far superior to what we've used. My research is into stainless steel-based material, mainly because many plants around the world still have stainless steel steam generators, because replacing them with the new ones is really expensive. These things are hundreds of millions of pounds each. So if we can solve a problem and people don't have to replace their steam generators because of a failure, all the better.
Power plants that rely on other types of fuel essentially work in the same way by heating up water to generate steam to turn a turbine. So do we see the same problems in gas-fired plants and in coal-fired power plants?
Not so much. The issue with conventional plants, and by conventional plants I mean oil and coal and gas, they generally use something called a supercritical water, which means the water has been heated up above 374 degrees Celsius, and it's at a very specific pressure, which I can't remember off the top of my head. But what it means is that the water is no longer either liquid nor is it gas. It's actually in a completely new phase of its own. This new phase means that each unit of this water can carry a lot more heat than either steam or water liquid can carry on its own. So as you increase the temperature at which you're burning your fuel, and as you increase the temperature of your coolant, you're actually increasing the efficiency of the fuel that you've burned. So you're getting more energy out of the same ton of coal or oil that you've burned. Nuclear power stations don't work in the same way precisely. They do work by heating up water, but they don't work in the supercritical region, because there is still a question of what will radiation do to water when it's heated up and when it's in the supercritical regime.